Well, hi, good morning, and thank you so much for joining me here in my shop on August 24th. A very gray day here. In fact, all of Ontario is gray today. I don't think we're going to see any sunshine. And cool. And just south of me by a few hundred miles, or maybe a bit more, is a steaming cauldron of Americans who are being cooked out in a big heat wave bubble that's in the middle of the United States, but not up here. It's quite cool up here. Okay, so we're going to start on this radio. I can tell you this about this radio. I have it. It's here. That's about all I know about it. And it's missing a knob. I think that's a little obvious. So I'm seeing it really for the first time too. And spin around. Seems to be in fairly good shape for such an old radio. It's an AM only radio, so its only job is to do AM. And hopefully it has a fairly large speaker here. And it has a, I guess the manufacturer's name here is Co-op, as in C-O-O-P. Can you see that there? Co-op. Broadcast Co-op. Co-op, that's interesting. Now, I happened to live in a co-op when I was going to college, a cooperative apartment building of some fame called Neil Wyzik in downtown Toronto for the Ryerson University. It was a housing co-op, had 700 students in it, a 22-story high-rise tower, run completely by the students inside the building. There was no owner, it was a co-op, which means it's held by a co-op corporation, and the membership of the co-op operate the corporation, but the capital is held by the corporation, not held by the members at all. So that's the deal there. Interesting. Co-op, housing co-op, still exists, I believe, today. One of the last surviving large-scale student co-ops in North America, I think. And I'm happy to say I was the president of it for a while. Okay, getting back to this. Is this really co-op? Co-op radio? Never heard of that. Oh my gosh. Well, here's something I have not seen before. Made expressly for Interprovincial Cooperatives Limited. Never heard of this. Interprovincial Cooperatives Limited. Built by Brand and Millen. I've heard of them. In Long Branch. Long Branch was a community that's now part of Toronto. Model 751. Serial number, looking for kind of a date on it. Just looking at it, I would say it was early 1950s, offhand. Interprovincial Cooperatives Limited. Interesting. Warning, any person installing or operating this receiving set without having first obtained a license from the Minister of Transport of Canada is liable to a fine not exceeding $25. And the said receiving set may be forfeited to His Majesty. Hey, it is His Majesty once again, because the Queen is gone and there's a king there again. Gives you an idea how old this is. This predates Queen Elizabeth. His Majesty, by order of the Minister, for such disposition as the Minister may direct. In other words, take your radio and they'll sell it. You'll never see it again. Or maybe even destroy it. It's a nice looking piece of wood up here, although it's damaged a bit, but it's got a nice kind of look to it. Okay, well, we could plug this guy right in and see what happens, but I think in this case, in most of these cases, it's wiser to have a look inside first and see what's going on. So I acquired this kind of from an estate sale, sort of, but not really a sale. Really, some gentleman passed away and his wife liquidated his electronic collection and shop and whatnot, and when she couldn't get rid of any more things, she found me. And I was the cleanup man. I got all the remnants that nobody, it was picked over remnants. Not to complain though. Ended up with some interesting stuff. If you are watching a lot of my videos, you've probably watched me work on some Citizen band radio equipment. That all came from there. And a couple radios, including the one I just finished, came from there. What's going on? This is a machine screw, and these two are wood screws. That's a little odd. But then again, how surprising is it that there's a mixture of screws on here? So, looks like there's some rivets, so it looks like the back is riveted right to the chassis. Pull this knob off. Okay, pretty sure I've got a matching replacement for that one. And I'm going to guess there's a bunch of screws down here. One screw. Somebody's doing a little arithmetic here. 104, 81, 186. Height. Okay. I think I'm going to set this down and hang it over the edge here. The co-op movement was quite strong when I was going to college. And there was a number of student housing co-ops built by the same people, basically. A number here in Ontario and a few in the States. They were associated because they'd all been built by the same group. Built by a group and then handed over to a, this isn't going well, to a co-op set up to run it, in perpetuity. They all failed one way or another, except for Neil Wyzek in Toronto. So I believe it's the only survivor of this five or six large student housing co-ops. And housing, we have a big housing problem in Canada. We have many immigrants coming, new people coming, which is great. We really need that, but we have no place for them to live. And it's put pressure on housing for everybody, of course. And the result is we have a housing crisis, a serious housing crisis here, which is manifesting itself in the form of high prices and shortages at the same time. I guess those things go together, don't they? Because, what creates value? Scarcity. Scarcity creates value. And it sounds totally counterintuitive, but the capitalist system is all about maintaining a level of scarcity. If you don't, there's no value. Okay. So we got a couple screws here. We wanted to take the antenna off. We could, but why would we? Let's see. It's a loop antenna. It's got 4 leads coming off the turns. Two wires making it into the radio, and a wire extended out the back in case you want to hook up a long wire antenna. But really, that would never be very helpful. You're really much better off with the loop antenna and trying to listen to fairly local stations, or at night you could listen to a distance. So all the tubes are in here. It's got a big Christmas tree. Well, not by today's standards, but what would have been a Christmas tree bulb. That's how you would have called that. I haven't tuned it yet, does it? Yeah, okay. So the string is there. Very good. Well, it looks to be in quite good shape when I look at it like this. Let's flip it right over and look inside at its guts. Let's look at its guts. What has it got going inside here? Well, well, this certainly looks like an original capacitor here. You can see the ends are kind of popping out of it. wax is as soft as can be. Got, looks like probably an electrolytic one here, 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 here. Why so many? We have another big one over here. This one does not look to be electrolytic though. We have a large one back here. We got a big resistor here. And what is this? This looks like a little sheet of asbestos shoved in here. Pretty sure that's what that is. And you have this hot, what I imagine to be a hot resistor up against the asbestos. Why would they do that? That doesn't sound right. That's really, I think, wouldn't you want this to be almost in contact with the metal back to draw the heat away? You're putting a piece of asbestos in here, you're insulating this resistor from the chassis, making the resistor hotter yet. Just a little bit surprising. Plus, you know, what's the concern? The resistor is going to get so hot it's going to set the chassis on fire? No. It's going to set the cabinet on fire. So shouldn't this sheet, it's definitely stuck in here, shouldn't it really be on the floor of the cabinet if you want to try to reduce the heat transfer? And the reason for using asbestos is it just will not catch fire. It's rock, right? So it's not going to catch fire. So you could use this to insulate something that's quite hot, I guess is the thinking when using asbestos. And also, a lot of these radios have a complete asbestos sheet in the cabinet. Where'd it go with the cabinet? But look inside here. No, there's no asbestos sheet. Was there ever one? Don't think so. A little hard to say for sure. It doesn't look like it. Chances are it would still be there if it ever was there. Okay. Well, it looks like it's in good enough shape to try operating. I don't think there's any question of that. Just interesting to note there's an adjustment here underneath the chassis. Something a little early to make notes like that, but why not? Anything else in here? Let's flip it back over. What do you say we turn it on and see what happens? I'm going to make a guess that this radio operates quite well. That would be my guess. That's been done correctly. See how the wires are swept around the pins, apart from each other? And it's a pretty old plug here. This is probably the original cord. I don't know. It's been tied up like this for a long time. I'm just checking it for any obvious breaks. Right in here. No, it's in good shape. Yeah, I don't think there's any reason we shouldn't plug this in. Now, I wouldn't plug it right into an outlet and let her rip. That might not be a good idea. What I will do is I will plug it into this bench supply here. This goes through a couple light bulbs if I choose. These two light bulbs here. And off to the outlet from there. No, not even then. It actually goes through a transformer on the way to the real power supply. So this is an isolated, there's no ground reference to anything I plug in here, even though there's a ground prong here. Not to be fooled watching my videos, there's the ground prong plugged into the air. So there's no grounding taking place when I use this until I hook up some equipment. As soon as I start putting equipment on for testing purposes, then I'm applying power system grounds to it. But the thing is, I can restrict the amount of power, this is the main thing, coming to the radio initially in case there's a short circuit in here. Okay, let's give it a go. Okay, coffee break's over. Let's give this guy a go. Here, this has got to be volume and of course tuning. I noticed that capacitor plates here. A couple things. First of all, this is the same size as this. That means there's probably a series trimmer capacitor for the oscillator part of the capacitor. So it's either oscillator here, an antenna here, or the other way around. If you notice, the plates here are bent out. The two outside plates have been bent out a bit. That's not a mistake. That's done in the factory as part of the tuning process in particular. If you notice too, these outside plates are split. They have splits in them. A split, you can kind of see it on the top here. A split, and that's to allow different portions of this to be bent outwards. You can't really bend them inwards because they'll end up rubbing on the stator plates. And so this gives you a chance to sharpen the matching of the pointer position to the dial numbers. So this is not a linear situation here. It's just about impossible for engineers to make it perfectly linear, and some of the last steps that can be taken to try to match it up is to fool around with these plates. So you see them bent out. Don't bend them back in. Don't just leave them. They're probably done under a very careful, they're probably done with a lot of care. Okay, that's enough talk. Here we go. Switch is off. Checking to make sure that the off switch actually goes off. Okay. What am I hearing? Oh, I know what I'm hearing. I'm hearing the pointer on this meter, which is going way over. So we're just going to cut this back a little bit. Okay. There we are. So I actually have another way to control the kind of power that's reaching this unit, and that's through this control box here, variable power supply. Okay, so 112 volts on the plug. As soon as I snap the switch over, actually I won't do that, but when the set is on and the power is applied, some of it, all the supply power will go through these bulbs. They will come on. You will see them glow briefly, and then as the current draw in the radio varies, as you first warm it up, these lights will go dull, and then they'll come strong again. And as they come stronger again, and strong maybe not very strong, we should start hearing the radio. That's how it should work. Power off, switch is on, and there's also a light bulb in here which is going to blast away at us, assuming it works. Here we go. Okay, so the lights came on and went down very quickly. The dial light is not working. Now we're just keeping an eye there, or an eye here, or even an eye here. And also looking for smoke. Smoke and flames. Nothing happening. These radios generally will work with 100 volts on them. The volume might be a little lower than it would be otherwise. Also, when you have restricted supply voltage, they take much longer to warm up. So I'm just giving it time. The volume is still right down, so I don't hear any hum. I don't hear anything. Okay, we'll turn it up. Beautiful. No hum in the radio. Lovely. There may not be much to do with this radio. So generally in the area I'm in, stations are picked up at the low end of the dial, starting at 680, 640, 610, 590. 590 is the strongest station. Let's see what we can get. So I'd be hoping 680 would come in around there. Now the dial may be inaccurate, and the antenna is directional. You hear it? I hear it. Let me turn it up a little bit. So that sounds like 680. 680 is a news channel. It's very weak. lot of radios have trouble picking up this station because there's a noise signal right adjacent to it. At least here, at least there was. It used to be, not anymore. Not today. Let's go further. And now I know this is the proper angle for Toronto. That's where that station was coming from. I actually think the transmitter for 680 is located on the far side of Lake Ontario in the Niagara Peninsula, on the edge of the lake in a town called Grimsby. I believe that's where the transmitter is. It's actually quite far away. This 590. So there's the interference sounds are coming from external to the radio. They're not coming out of the radio itself. It's not a problem with the radio. It's the problem with being in my shop here trying to operate these radios. So those are working really quite well already. Makes me wonder, what would I bother doing with this other than put it back in its cabinet? Claim success already. Let's turn it off. Turn it off. Cut the power. Yeah, like, you know, what am I going to do? Change all the capacitors? It's actually operating. I don't really see much advantage to doing that. There's a couple in here I'd probably be wise to go after. One in particular, and I'm going to guess it's this one that's already been replaced. Looks like it's been replaced. Would be the grid blocking capacitor for the output tube. If we look for the output tube, we will find it. I think it's this one, in fact, down here. So this fairly large capacitor here, let's just see if we can find the voltage rating on it, plus and minus. 10 at 25 volts. So the purpose of this is to bypass the cathode resistor, which is providing the bias in the output tube here. A little too close for the focus. So this has been replaced, and there's no reason to replace it again. This just doesn't look original. This is probably the blocking capacitor. This looks terrible, but we're going to find out. So first of all, I don't have a schematic. I'm going to take a moment, see if I can find a schematic for this radio, and it would just be a big step ahead if I can. So I'm going to try to hunt for one here. I think it's worth showing you this. Rather than search the usual way for a website that contains a schematic for this radio, I just typed into the Bing chat system here, using their AI power. I typed in, please find a schematic for a Brand and Millen 751 radio. And the response I got was this. I found some information about the Brand and Millen 751 radio. It seems to be a Canadian model that may share the same schematic as the Astro model DR102. I could not find the schematic online, but you may try contacting some antique radio forums or websites that offer schematics for Canadian radios. Hope this helps. Holy smokes! Well, can it get any easier than this? So Astro model DR. So what if I click on that? What if I just click on that? Well, that's the radio I've got. That's the Brand and Millen. Brand and Millen is a manufacturer making it for the Co-op company, I guess. I don't know who Co-op was. Apparently Brand and Millen was often in the background making radios for various brand names, other brand names. Okay, so this didn't work because they don't have the schematic here. So that didn't quite work. So Astra, now I just want to copy, come on, can't I copy that part? Astro model DR102, let's try that. So we'll go here, we'll go home, we'll go DR 102 from Canada, and that's all we'll say. So it's a very similar looking radio, no doubt about it. And here we've got some information here. And the first sheet appears to be upside down. Okay, so I'm going to get this, and well, let's get it. We will get it. Now. I'm a member of Radio Museum. So here we are. We can look at it right here. Oops, not like that. Okay, so we look at the layout first and see if it matches. Now I'm just going to do that myself here. I'll just take a look at the radio and see what we got. We've got one tube out of the row right here. We've got a transformer on an angle here. We got the capacitor shoved in the corner. And that's it. This is exactly how the radio's laid out. So I'm going to guess these are all the same tubes here. It's a 5-tube set, no transformer. This is the audio transformer for the speaker. There's no power transformer. It has a permanent magnet speaker in it, of course. It's not. The IF is 456, not 455. Okay, very good. And parts list, excellent. And how to align it. Wonderful. Got it all. Short oscillator section of gang through point 1. Capacitor to the chassis. That's to shut down the oscillator. If you want, before proceeding with RF alignment, see that the pointer, so we have to set the pointer properly, of course. Okay, that's down the road, I think. So what we're interested in the schematic here, is the capacitor feeding, blocking the grid. So here's the grid. Oh, this tube's upside down. Okay, so here's the grid up here. Yeah, they have the tube upside down. This is the blocking capacitor way over here. C14. Okay, let's see 14. C14 0.01. Okay, that's very typical of a capacitor in this position. 0.01. Now it's hooked up to pin 5 and the plate, yeah, of course it's taking the signal from the plate circuit of the previous tube, passing the audio signal through, blocking the DC. And this is the problem, it's probably not blocking the DC. It would be on pin 5 of the 35L6. Okay, whoops, pin 5. So let's take a look back in the radio. Output tube is over here. Did I say pin 5 or did I say pin 6? Oh my gosh. Yeah. I got a memory like a steel box. Nothing gets in, nothing gets out. Let me just take a peek again. Pin 5. Yes, it's 5. Okay, so we'll count here. Okay, so I'm looking for the little key. Here it is. 1, 2, 3, 4. This is 5 here. Not here at all. Did I count those right? Sure. 1, 2. This is on pin 3. Let's have a look at pin 3 on the schematic. Pin 3. Pin 3. Here's 3. That's this capacitor here. Not quite as important as this one. We still need to find this one. But it's probably, considering what it looks like and the fact, yeah, we should really change this one too. Just noticing here, important things that need to be noticed. The speaker is not completely isolated. It's got a connection back to the chassis here. It's important things to make note of while you're working on these radios. Okay, so what about this pin 5? There's a mica capacitor sitting there, 0.01. I can't imagine this is mica. Let's trace that down in the radio a little more thoroughly. Okay, so we're going to come off pin 5. Let me count it again here. 1, 2, 3, 4, 5. This is pin 5 here. Well, you know what? Can you see it? It's hard to see. But way down under there is a brand new Sprague capacitor that somebody's put in. So someone sort of at my level has been through this radio. And they've picked off some critical stuff. Now they've left this big guy in. He's probably on the screen circuit, but I don't know for sure. They left this ugly one in. Probably worth changing it just because, look, who wants an ugly capacitor like that in their radio? And considering the radio seemed to be operating otherwise, I think we should just go ahead and change this one out. And I will do that. I can cut it out right now and test it before I shut the camera off. So I think the main job of this one is to stop oscillations in the output circuit, and maybe other things. I'm not as expert as I could be in this kind of stuff that I'm doing here. So it looks like it says 0.08. You can see the shell is the wax is not sealing it here at all. So, and look at it. It's ugly. Okay, we're going to take it over. We're going to give it the test. Come down here. Now, if you hadn't seen this being done before, this is a capacitor testing device. Back in the day, this would be a very valuable tool. Not so much for today's modern electronics. This is not really an appropriate test for capacitor for modern electronics. This is going to apply a high voltage to the capacitor, and then this eye is sensitive to any current that's leaking through the capacitor. If there's no current leaking, which would be good, then the eye will look pretty much like you see it now with this open pie at the bottom. The more the leak, the more closed the pie is. On 50 volts, a bad capacitor, this eye, when I apply the voltage, won't even open again. Here we go. Open right up. 150 volts. No, not opening. Let's go back to 50. Yeah, something funny happened there with that first test. Now you can barely see, the eye is actually open, just a crack. It's definitely a leaky capacitor. In that position, a small leak might not have much influence in the operation of the radio, but it's not desirable, that's for sure. Really not what you want going on in your radio. So what I'm going to do is obviously going to put another capacitor in, and then we'll think a little more about this, maybe fiddle with the alignment a bit, something like that. Okay, I've replaced that capacitor. You can see this nice one down here, and let's take a look at the schematic again. What we want to look at is the power supply fairly carefully. Now, where's the plug? This must be the plug. You shove in the wall. You can see it's a 120 volt light bulb right across it. Christmas tree light bulb. And what we want to see is any connections to the chassis. So, for instance, this one. This probably represents the frame of the, it may represent the frame of the speaker, which may be internally connected. You see how these coils are connected. So this might just, there's no wire, it might just be the bolting of the speaker frame does this. see the outside, like the can that's around the IF transformers, is hooked up to the chassis. Of course, it's sitting right on the chassis. They're not insulated in any way. Same thing here. You can see one more here. This one is obviously related to the antenna. And then all this is all connected to the chassis. Now, this line here is probably the B minus. Maybe the opposite, maybe the B plus. Let's just verify what this is. It's going to the cathode. So this is the B minus line here. And between the chassis and the B minus line are these two components here, C9 and R3. And we want to make sure these two are correct. The resistor's probably fine. This capacitor, though, if this is a leaky capacitor, the danger level of this radio increases. So let's see, this is capacitor number 9. 0.2, that's a fairly lot. It's a big guy. And now a little secret. When I was looking in the back of that radio at that big capacitor, I noticed one end of it is soldered to the chassis. So this big thing is this thing here. That's unusually large for this position. Typically, if we follow the screens now, we have upside down tubes here, throw me off. Here's a screen here. This is the screen line. And now they could be relying on the power supply capacitors to filter this line, but typically they stick another capacitor in. But I don't see one. Okay, often there's a large, 0.1 or something like that. Be running from this line to the B minus. But I don't see it. So they must just be relying on the filter capacitors here, unless it's somewhere else and I'm just not getting it, which is always possible. Okay, so what about this thing? Big 0.2 here. Boy, that's pretty big. It would allow more current through. So if you touch the chassis, maybe you can do that through the antenna. You're playing around with the antenna, you're in your backyard, the radio's on an extension cord, and you're not wearing any shoes. Grabbing this radio chassis or the antenna could be the last thing you do on the planet. If this capacitor is not much of a capacitor and much more of a resistor. This guy, R3, is probably 150K or something like that, R3. Ooh, 1 mega. Ooh, way bigger than expected. So much bigger resistor, much bigger capacitor. Don't know why, but these are large compared to what you find typically in a radio. Well, I think we're going to have to do the C9 here. We'll have to do this 0.2. I better find one. I better find one in my among my capacitors before I cut that one out. There's a chance this big capacitor is just fine. Well, I didn't have to look long. Right here in my 0.25 tray, I've cut these. 0.22, 400 volt Sprague. These are really good capacitors. Good. Okay, so I've got a replacement. We're talking about this big guy here. We're going to cut this one out and give it a test and change it no matter what the results of the test are. But my guess is it's going to show up leaky. Philco 0.25, made in Canada. Good old Canadian made capacitor. After the Second World War, the governments around the world that were involved in the war had a big problem. That's all these soldiers coming back what are you going to do with them all? And the second problem was factories full of the wrong stuff. Full of the wrong stuff. When the war ends, the factories stop and they're full of stuff. And the government says, we don't want that stuff anymore. We don't need the tanks, we don't need the bullets. But the factories are not only full of the materials, they're full of the machines designed to build the war materials. So governments, certainly here and in the United States, took fast action to try to avoid having a whole bunch of listless, mentally injured men stumbling around the country with nothing to do. So one of the newfangled things was radios. Radios were new, well, they weren't really newfangled, but one of the things that could be done is using the advanced technology, the technology that advanced during the Second World War, build better radios and sell them, and that's what happened. So a lot of war industry was located in a city called Ajax in Ontario, and right in that area, because all these warehouses and factories were useless, radio companies set up shop and started making radios. That's just and the interesting part of this story is the problem of having factories full of stuff that nobody wants anymore. And it happens, right? The wars end kind of unexpectedly. You're kind of going full bore until the day it ends. And the day it ends, there you are. Okay, let's check this guy out. Now he's a bigger capacitor, takes longer to charge, so we would expect the pi to close and then stay closed for a moment while the capacitor charges up. Let's see if I'm full of crap. It's charging. You can't see it, but the eye is trying to open, but it's not going to get there. Not going to get there. Are you surprised? A big capacitor would have a big leak? That should not be surprising. Now I'm going to put a short on this and leave it aside, and if I can remember, we'll do an interesting experiment with it. That's only if I can remember. I do this all the time where I know what I'll do. I'll do this. And then I forget it completely. Just leave that guy there. Short it out. Okay, so I'm going to install this beautiful orange capacitor in the radio here. And then after that, I think really the next step, like this is making the radio safer. The next step will be to fill around with the alignment. I think that's really where we need to go with this radio. Okay, and we'll do that. Install the capacitor. Okay, let's do that little experiment before I forget. So I've had the short on the capacitor here for 10 minutes anyway. Surely to goodness, if there was any charge in there, it's long gone. I have my voltmeter here. Now I left this voltmeter on for an extended period, so just maybe the battery is not as good as I would hope. This is a very high input impedance meter, and it'll read as low as, this is a 1 volt scale right now, but it'll go as low as a 0.3. So what we're going to do is we're going to look for DC voltage in this capacitor, not remnants of a charge voltage, a different voltage. What does the meter say? It says nothing. So this is the thing about doing these things live. Yes. Sometimes things just don't work out. Okay, so there's a little tiny voltage in there. Now I've gone this far, I have to try this with any other capacitor. So this has been sitting around for a week or more. It should have no voltage in it, and it has no voltage in it. And there is the demonstration. Has this ever happened to you? Let me show you. Well, it's not doing it. There we go. You see the little rise there? And then it just fell back because the meter drained out its charge. Okay, so regardless of my lousy demonstration, what I'm trying to show is that these capacitors can get a moisture level inside them sufficient to start some electrolytic action. There's different metals inside the capacitor. There's plated steel lead coming in. It's somehow attached to the aluminum foil that's inside, whip in a little bit of moisture. I've had capacitors, not today anyway, but I've had capacitors of almost a volt of output from them. Now, you can't run a light bulb with it because when you try to draw current, these are terrible batteries, and instead of supplying current, the voltage, the pressure in them collapses right away. But do you want to have something like that in your radio? Maybe in a very, very sensitive place, maybe in a high impedance circuit? Probably not. So anyway, you'll have to trust that this can happen, because my demonstration showed otherwise. Now, what are we going to do with this radio? First, we got to operate it, make sure it's still working. But I think alignment is really a possible place to pick up to improve the operation of the radio. I'm not sure changing more capacitors is going to do it. Okay, so we're going to operate it here. Switch on, watching those dim lights. If there's a short circuit, if I booped up or dropped a wire in there and shorted it right across the power line, like a dead short in here, all that will happen is these lights will come on very bright, and they'll stay bright, and the amount of smoke that evolves will be reduced tremendously. But I don't expect that. So you can see the bulb came on briefly. The current is rushing into the heaters of these tubes. Once the heat comes up pretty quick, the current rush goes down, and you see the bulbs go down. And now, as the radio starts to operate, it will draw more current again. And sometimes in a bigger radio, these bulbs will come back on. Not in this one. So we're running with 105 volts. That's good enough. Tune again, just in case something has changed here. Now, there's a good chance this radio is properly aligned, because it came from a guy not unlike me who probably aligned it and probably used the equipment. What I'm going to do is I'm going to adjust the alignment roughly and see if it gets better or worse. This is not the way to align a radio, but since I have the alignment instructions and I can certainly follow them, I can recover from any disastrous thing. So we want to find out, will it get louder? Nope. It did. It got a little bit louder there. This way. Nope. Well, if it's out, it's only out by a fraction. Let's try this one. I think that was out a little bit. Again, if these were out, they weren't out by much. Okay, anything more we can mess up? One of these is the oscillator, and one of these is the antenna here. Which is which? If you affect the oscillator, the radio retunes. If you affect the antenna, the radio goes weaker or potentially stronger. It sounded to me like it was going up and down on its own there. Maybe not. Oh, yeah. Okay, loose tube. Or bad tube contact. This is the rectifier tube here, isn't it? No, this is the output tube here. Oh, one more tube. No, I don't hear anything happening when I wiggle them. Okay, so which one of these is the oscillator? So we'll interfere with its operation. So this one's tuning it. I'm just touching the stators here with my finger. This one appears to inject noise into it, but the station's not retuning. this one's definitely retuned. So this is the oscillator. So we want to stay away from this one. We want to find out if there's something weird about this antenna adjustment here. Not likely again, but let's see what happens. Not a recommended method, but this adjustment's usually made at the high end of the band too. I'm at the low end. Well, that quieted it down, didn't it? Not tuning it though. Looks like it likes a lot here. So the oscillator tuning is done here, and then if you remember, there was an adjustable capacitor underneath the chassis. And that's probably the series one. The two of them have to be adjusted, and that following the instructions you gave. Did this just get better? What happened there? That interference signal kind of disappeared briefly. The one that sounds like a chirpy sound. So the way it looks to me, there's not a lot that can be done to make this radio operate much better than it does now. That's what it looks like to me. So we'll get what I'm going to do, I'm going to stop for today. Tomorrow I will do the alignment and the final assessment on its operation, and maybe even put a new light bulb in there, and it's done. So not much to do with this radio. The other wasn't there another wax capacitor in here? So there's one here, there's another one down here, looks like, and one over here. Well, maybe we'll take a look tomorrow at what are these capacitors doing. Are they worth changing out? This one I can tell is carrying the audio from the volume control. I don't think there's a problem with the audio. This larger one, I don't know what it's doing, or this one offhand. We'll take a look at those, decide whether they're worth changing or not, and do the alignment properly. See what we can get out of the radio. That's great. Well, thanks a lot for watching, and have a great day. And I'll see you on the next video. See ya.